Welcome to Better Health Guy Blogcasts, empowering your better health. And now, here's Scott, your Better Health Guy. The content of this show is for informational purposes only and is not intended to diagnose, treat, or cure any illness or medical condition. Nothing in today's discussion is meant to serve as medical advice or as information to facilitate self-treatment. As always, please discuss any potential health-related decisions with your own personal medical authority.
Hello, everyone, and welcome to episode 196 of the Better Health Guy blogcast series. Today's guest is Justine Stenger, and the topic of the show is cellular wellness. Justine Stenger received her degree from the University of Alberta in nutrition and physical education. She proceeded to pursue a holistic nutrition therapeutic chef certification from Bauman College. Justine has completed her functional medicine training through the Institute for Functional Medicine. She is a trained Bredesen ReCODE practitioner and specializes in cell membrane medicine and works primarily with patients who suffer with neurological conditions, mast cell activation syndrome, Lyme disease, and autoimmune disease. Justine has worked beside Dr. Bruce Hoffman for the past 10 years and has supported hundreds of Dr. Hoffman's chronic complex illness patients nutritionally. And now my interview with Justine Stenger. The cell is the building block of everything in our bodies. And today we have Justine Stenger here to talk with us about cellular wellness. Thanks so much for being here today, Justine.
Thanks for having me, Scott. It's a privilege.
What brought you to the realization that cellular health is so critical in overall health? And what drives your passion for the cell, for the work you do today? And did you have your own personal health journey that led you to the passion you have today?
I think, like so many people that are in this field, I also had my own personal health struggles, which ultimately led me here. I was a very high-level athlete, which feels like a lifetime ago, but I played varsity basketball. And if anyone played high-level athletics in the 90s and early 2000s, they know that people really, really wanted you to train hard and without any breaks. So my reserve capacity was completely depleted in my early 20s. And then I ended up living in a moldy home when I was going to university, which was kind of the straw that broke the camel's back. And I actually got introduced to a doctor. My mom was seeing Dr. Stephen Jennis, and he's quite well known now for his work in environmental medicine. He's published dozens and dozens of papers, and he was still practicing as a GP then. And so I went to see him after seeing, many allopathic doctors who just prescribed me antidepressants. And ultimately, I knew that was not what was going on. And so I developed my love for really environmental medicine through learning from him. He provided these weekly lectures to his patients. And I decided to kind of pivot my career, and I moved to Boulder and I did holistic nutrition, and I went and did my Therapeutic Chef. I love cooking, so I did my Therapeutic Chef certification. It was really based on, cooking for specific disease conditions. And then I moved back to Calgary and I got connected to Dr. Bruce Hoffman. And as you know very well, he's kind of a guru in this whole cell membrane medicine approach. And so I had the privilege of being able to see these diagnostic labs completely transform through using lipid replacement therapy. And of course, he uses many other treatment modalities as well. But it was really the use of phosphatidylcholine that was restoring the cell membrane and the membranes of the organelles within the cell, the mitochondrial membrane. And I know we'll probably get into this in the interview, but the things like DNA adducts that were completely removed with phosphatidylcholine, complete restoration on a mitochondrial level using phospholipids. So that's what really, started that fire in me to want to go and pursue understanding the cell, understanding the role that phospholipids play in optimizing our cellular health.
I love it. This is definitely an area that I have a lot of passion for as well, and incorporate these things into my daily routine also. What symptoms that a client might be experiencing lead you to think about the cells as a potential contributor to their overall condition? What are maybe some of the key symptoms or conditions associated with poor cellular health?
Well, Scott, it's basically everything. If you look at Doug Wallace's work, which I've really been diving into recently, Doug Wallace and Robert Navio and Nick Lane have been major mentors of mine recently. And Doug Wallace has found that between 95 and 99% of disease that we see today is of mitochondrial origin. So between 1 and 5% are actually genetic diseases. So that puts all of the onus on our mitochondria. And these are really symptoms that manifest due to energy deficits. So something like a migraine headache, if you have a 5% decrease in energy production in the neurons, a migraine headache would manifest. So that's where we see these symptoms that arise. We really have to look at mitochondrial functioning and how can we optimize ATP production or energy production. And that's largely going to be through improving redox, improving the membranes so that all the proteins and the peptides within the membranes can function properly, and all the organelles within the cell. So just like the human body, every single organ, every single system works synergistically together. But the same thing happens within the cell. So all of our organelles are working together. And so when we're optimizing the membrane of the mitochondrial membrane, we're also improving the function of the endoplasmic reticulum, the peroxisomes, the nucleus, the lysosomes, because every single organelle within the cell has a biological membrane or it's interacting with one. So this is the significance of the membranes.
So we can't really get more foundational than our cell membranes.
We can't get more foundational than the cell membranes, 100%.
What are some of the factors that lead us to poor health of our cells, of our cell membranes? Is this more diet, more environmental toxicants, more infections? What are some of the factors that lead us to having cells that then need targeted support to optimize our systemic health? Life
downloads all impact our cellular health. I would say the environment probably plays the most significant role. And when we think about environment, we have to think about environmental chemicals. We need to think about electromagnetic frequencies, which we are living in a soup of these EMFs. We need to think about blue light toxicity and how that impacts all of these pathways and impacts us on a cellular level. And most of us are all living under this toxic blue light. We're looking at it right now. Luckily, I've got a filter on my computer screen. So the environment is huge, but nutritional deficiencies as well are going to play a role. When people end up with mast cell activation syndrome and inflammation and high levels of reactive oxygen species, that's going to damage the cell membrane. So there are dozens and dozens and dozens of things that damage the membrane, which is why it is so critically important. I know we touched on this a little bit before we started recording, but it's so important for us to remember that our body is just like a bank account when it comes to our biochemistry. If we become biochemically bankrupt, we lose reserve capacity. And that's ultimately when we end up getting sick. So the more that we can build that biochemical bank account and provide that reserve capacity so the body has what it needs to go in and repair damage when it needs to repair, the better we're going to be off long term.
How does a healthy cell membrane impact nutrient delivery to the cell and also waste removal out of the cell? Are we essentially optimizing everything in the body when we're optimizing the health of our cellular membranes and our cellular environment?
So yes, we absolutely are optimizing everything, because I'd mentioned before that the cell, if people could think about the cell membrane like the master control center, this is a semi-permeable membrane that is determining everything that is entering in the cell. So when we think about macronutrients, protein, fat, carbohydrates, their ability to actually get into the cell and get converted into energy is dependent on the health of the membrane, the structure and the function and the fluidity of the cell membrane. We have all of our proteins and our peptides that are embedded in that membrane. So when we think about cell-to-cell communication, when we think about everything that's happening within the cell, that is supported by the membrane. And when it comes to waste removal, I hear a lot of talk about detoxification protocols, how we can support drainage. Well, this is a cellular issue. So our cell has this miraculous ability to detoxify when we provide it with what it needs to actually clear those toxins from the cell. And phosphatidylcholine has a very unique property on its own, where it's able to actually work its way into the cell, which we were talking about, these DNA adducts, and can not only remove these intracellular toxins, but can also remove these DNA adducts that actually attach to both our mitochondrial DNA and also our nuclear DNA.
Let's talk a little bit at a high level about some of the tests that you might run to get a sense of a client's cellular health status, and then we'll dig into a few of those in more detail.
So we always run the IGL from Germany, which I know you're familiar with. That's an epigenetic mitochondrial test. So if anyone is familiar with Dr. Robert Navio's work, that test is really depicting his research. It's showing you every single thing that's happening on a mitochondrial level, or you can order those panels that are going to show you that. Then we also use the red blood cell fatty acid test from BodyBio, who pairs with the Kennedy Krieger lab at the Johns Hopkins University. And so that is going to show you the fatty acid concentrations on the red cell membrane. It's not only going to show you your parent essential oils, but it's also going to show you all the downstream metabolites. It shows you peroxisomal function. It shows you buildup of things like very long chain fatty acids, renegade fatty acids, trans isomers, saturated odd, which are inflammatory. And very long chain fatty acids are actually neurotoxins, so they're correlated with neurodegenerative disease. There's a myelination index on there. There's a stress index showing the level of stress that the peroxisomes are under. There's a fluidity index. So this is where, and I'm sure we'll get into this around essential fatty acids, where omega-3s, excess omega-3s can really wreak havoc on the cell membrane's fluidity because of those properties that it has and the impact that it has on omega-6 fatty acids, because those two essential parent oils compete for the same enzymes, the delta D6 desaturase and the delta D5 desaturase. So the higher you push omega-3, the more you're going to suppress omega-6. And we need omega-6 and omega-3 in a 4-to-1 ratio. So we need more omega-6 than omega-3. And when we throw off that ratio through supplementation, we can really cause a lot of damage on a membrane level.
So let's talk a little more about that test then. This is the BodyBio red cell fatty acid test. As you mentioned, it's run through Kennedy Krieger Institute. So what are some of the common patterns that you see? I think most people will be surprised at what you just said, that we commonly think of, well, omega-3s are going to be low and omega-6s are going to be high. My understanding is that that's not always the case, and that in some cases, the omega-3s are actually dominant and the omega-6s are deficient. So talk to us a little bit about the patterns that you see, and then why is omega-6 not necessarily bad, but in fact necessary for ideal health?
So I'll tell you, Scott, that this narrative that I hear people talking about, I just do not see clinically. I would say 1 out of every 10 tests will have an individual that has high levels of omega-6. 9 out of 10 people have high levels of omega-3, and they have actually suppressed their omega-6 fatty acids because of omega-3 supplementation. So I'm not sure if it's just the demographic of patient that we see, because we tend to see, if you're familiar with Dr. Bruce Hoffman's work, he specializes in chronic complex illness. He often sees patients that have been to many, many other functional medicine or integrative medical doctors. And so I don't know if it's because these people already have a little bit of insight into what they think is healthy. And so they take fish oil because they're told that fish oil is a healthy supplement to take. And that's why we see those results a little bit skewed, or if it's just an assumption that people that are consuming a standard North American diet, that are getting exposed to these rife industrial seed oils, would have higher amounts of omega-6 to omega-3. And I do think that that is a strong possibility, because most people that are eating out of a package or a box or a bag, and they're not eating seafood, you would end up accumulating higher levels of omega-6 than omega-3. But the problem with that narrative is that we are talking about 2 completely different categories of omega-6. So an industrial seed oil is oxidized, it's riddled with aldehydes. This is a toxic food. I wouldn't even call it a food. It shouldn't even be allowed in the food system. So now we've grouped both functional omega-6 that's found in many, many whole foods. Very high levels are found in seeds like sunflower, pumpkin, sesame, hemp seeds. And now we put all of these omega-6 under one umbrella and classified them all as bad. And that is just so far from the truth. And I think it's important for people to remember too that these essential fatty acids are essential nutrients. And if you look up what happens when an individual, a human being, does not support essential nutrient status in their body, if they don't have adequate amounts or if they don't have those nutrients in the proper ratios, the consequences of that are disease and death. So to tell people that omega-6 fatty acids are inherently bad or inflammatory and shouldn't be consumed is just a complete and total misunderstanding of cell membrane medicine.
I love that. And let's maybe go a little deeper into that, because I think there is a lot of conversation happening today by some big names that I'm not going to mention that are talking about linoleic acid and essentially kind of framing linoleic acid, which is in some omega-6s, but framing linoleic acid as a toxin and trying to deplete it as much as possible in their diet and make sure that they're not bringing any of that into their body. One of my personal favorite components, besides the PC, of course, of my daily power shake is the Body Bio Balance Oil, which has linoleic acid. And I really want to just kind of get a little more of your thoughts around the disconnect that we're seeing now, because there are big voices that are talking about the fact that linoleic acid is bad. And then I've reached out to several people who are experts in this lipid realm, you being one of them, that have a very different perspective. So why is it that so many people now are not making that differentiation between unadulterated linoleic acid, which maybe is very healthy for us, versus adulterated linoleic acid, which maybe is in fact toxic? Why is it that everything's been kind of lumped into this seed oil conversation and all seed oils are bad?
That's a really good question, Scott. And I'm not really sure how we ended up here. I think that this translates to so many different areas in allopathic or centralized medicine where we have this very myopic approach. We look at things with this very myopic lens. And even when you look at the research around omega-6 fatty acids, a lot of these studies are done on corn oil, on soybean oil. They're not using whole food sources. Now, the difference between consuming whole food sources of these oils or oils that have been cold pressed, that have not been processed with hexane and solvents and bleaches and deodorizers, this is a completely different, animal. So to group them all together, I have no ability to understand why we do that and why there isn't that differentiation. And I also think, frankly, it's dangerous to be telling people to avoid omega-6 fatty acids. And I have personally spoken to some of these really big names out there that are sharing this narrative and offering to do red blood cell fatty acid tests to help them to understand that this is not the case, to look at this through the eyes of a clinician and see that if you want to tell me that the Body Bio Balance Oil is harmful, then why do we see it improve so many patients time after time after time after time? Why do we see markers like melanaldehyde and these lipid peroxide markers all come down when we introduce things like the Body Bio Balance Oil and the phospholipid complex? So as a clinician who's been working in this field of membrane medicine for almost 12 years now, and seeing this time after time after time, it's, the curiosity of knowing, okay, there are research studies that show you that omega-6 can be inflammatory, but clinically it doesn't translate to that. And then when you look into it a little bit deeper and see that linoleic acid, which is that parent oil, the conversion to something like arachidonic acid, which everybody deems as inflammatory, which it's not inflammatory when it's in the proper concentrations. There's a Goldilocks effect. And arachidonic acid not only makes pro-inflammatory mediators, but also anti-inflammatory mediators. Arachidonic acid is the main fatty acid that's found in myelin. So I would hope that nobody is wanting to deplete one of the main fatty acids that's supporting their brain. Arachidonic acid and linoleic acid are predominant in immune cells, in your liver cells, in your skeletal muscle cells, in your endothelial cells. So when you start to look at it through that lens, then none of that makes sense. That narrative makes no sense at all. So I think that it's also based on this whole belief that everybody has really, really high amounts of omega-6 and that everyone needs to support with omega-3s because omega-3s are anti-inflammatory, which I also struggle with. Yes, they are involved in the production of resolvins and protectins, which are incredibly anti-inflammatory, but they also suppress the immune system. So of course, you're going to see all of these beautiful immune, markers decrease, these inflammatory markers decrease as you load on the fish oil because they have immunosuppressive qualities.
Have any of these voices against linoleic acid that you've spoken with and offered to do some testing, have any of them taken you up on that offer?
Yes, they have.
And have you shifted their perspective at all?
Unfortunately not, because it was somehow justified. So, I think that sometimes we can get really stuck in this fixed mindset of thinking. And then at that point, it doesn't really matter. I don't think what anyone says or what the evidence shows. The belief system is set.
You mentioned the term parent essential oils. I first heard that term from the work of Brian Peskin over a decade ago. He definitely is not a fan of fish oil, also talks about some of what you were talking about, suppressing immunity. It sounds like in some cases, the reduction of inflammation may actually be almost acting more like a steroid, where then the immune system is suppressed. Sounds to me like that may not be the best thing for people that have chronic infections, to kind of be suppressing our immune system. So in cases where a client is in fact deficient in omega-3s, when you do the red blood cell fatty acid analysis, how would you support that? Would you in some cases use fish oil? Would you use algal oils? Would you use parent essential oils like those that Brian Peskin talks about? And what are your thoughts then on SPMs or pro-resolving mediators? A lot of these products are becoming very popular these days as well.
So SPMs are fish oil. They're CO2 extracted fish oil. I have a pretty strong opinion on fish oil. So, I think that there may be people that have a more moderate take. I don't ever recommend fish oil. I think that the way that we were designed and should be getting our omega-3 fatty acids is from whole food. And I will stand by that till the day I die. So even when you look at studies on oxidation, Scott, that the fatty acids in whole foods don't oxidize through cooking. And I just think it's a completely different ballgame when we're consuming these whole foods that we were designed to eat. I think when you start extracting specific fatty acids from whole foods, that it can be, and then taking high doses of them, that we can probably run into problems. But one of the biggest problem that I have with fish oil is that, so DHA has 6 double carbon bonds. So it's incredibly susceptible to oxidation through heat, light, oxygen. And so my concern is that the majority of people out there are likely consuming an oxidized oil on top of distorting their essential fatty acid status. And we want that 4-to-1 ratio, like I mentioned before. And then also we're giving fish oil to a lot of these people that have chronic conditions. I know it's a big part of the Shoemaker protocol. And so when you think about these people that have high levels of inflammation and poor redox, so high levels of reactive oxygen species, well, what is going to happen to those fatty acids when they're in the membrane? Low levels of phospholipids and excess DHA, that's going to get oxidized. So we just end up, creating a bit of a mess. And that's where I would say eating the whole food is always the best option. I think there are good, better, best options in the supplement industry. Like I know BodyBio has a fish oil supplement that is CO2 extracted. So they very carefully extract those oils from the fish. And that would be a lot safer than a company that's using, say, a steam extraction method and then adding in lemon and flavoring agents so that it's really hard to detect rancidity.
What are some of the key foods then that you might guide your clients to incorporate? Is that primarily going to be fish if we're looking for omega-3s, or are there some other ones that we should consider as well?
Primarily fish. I'm a big fan of shellfish as well, just because they're so rich in minerals. And of course, this is always wild caught and, really high quality food is what I'm always recommending and promoting. So wild caught salmon, sockeye salmon, coho salmon. I encourage people to stay away from Atlantic salmon because there's a farmed fish now that's been named wild Atlantic salmon. So you have to be a little bit careful with that, and they're being very sneaky. But sardines and mackerel and anchovies are all great sources of those fatty acids. So I like people to consume an array of different forms of seafood and different types, and to be consuming it about 3 times per week to keep those fatty acid levels where we want them. And then to be supporting with the balance oil. Seeds are also a great source of those essential fatty acids. Like I mentioned before, sunflower, pumpkin, sesame, hemp seeds all have a really beautiful linoleic acid ratio.
And so if we were looking at omega-3 and someone said to you, I just don't eat fish or any shellfish, or they're maybe allergic to fish or shellfish, would you then use the balance oil, or would there be other things you might use supplementally to increase omega-3 if that was even necessary?
Oh, caviar. I would recommend caviar. Or, trout roe or salmon roe or something. Those are excellent sources of omega-3s. And actually, the omega-3s in those foods are in phospholipid form. So you're getting a nice amount of phosphatidylcholine as well.
And can someone get these in a supplement that you actually feel comfortable with, or do they need to be eating caviar?
I would say eat caviar. You can get pretty inexpensive forms of caviar. I get some from the farmer's market that is about $18, and it's enough to last for the week if you're doing just a couple of teaspoons every couple of days. So for people that completely refuse to eat fish, I try to educate on the importance of it and try to encourage them to find a form of whole food that they can consume, even if it's not their favorite thing. And then if not, I would recommend something like the Body Bio fish oil, because it's really a nice low dose. So it's not overwhelming people with omega-3s. And then it is CO2 extracted.
Let's talk a little more about the Body Bio red cell fatty acid analysis test. So when you get the report back, it kind of frames the results in terms of burn it, build it, balance it, and stabilize it. So wondering if you can just kind of at a high level, I know we can't go too deep into it in this conversation, but can you talk to us about what each of those sections conveys to you, and then building a little bit more on your earlier comments about the very long chain fatty acids and the renegades? What are those telling you, and what types of interventions might you then consider based on the results someone may get from their fatty acid analysis?
Okay, I love the red blood cell fatty acid test. I'm excited to talk about this. So in the burn it section, that's showing you peroxisomal function, and you can get a really good idea of mitochondrial function as well, because we know that the mitochondria and the peroxisomes work so closely together, specifically to beta oxidize these fatty acids. So if the mitochondria are stressed and then they're pushing these fatty acids to the peroxisome, and the peroxisomes are stressed and they're not able to break these fatty acids down like they should. So the peroxisomes will take these fatty acids that are sent from the mitochondria, they beta oxidize them down to an 8 carbon chain fatty acid and then shuttle them back to the mitochondria. Now, when that's not happening and the peroxisomes are stressed, we end up getting a buildup of these very long chain fatty acids. And these accumulate in the cell membrane and are incredibly inflammatory. And so they're impacting cell-to-cell communication. They're going to be a trigger to the immune system. And I mentioned before, they're actually directly correlated to neurodegenerative diseases. So we want to not only support the mitochondria, and we want to support the peroxisomes and really every organelle within the cell. And then we want to clear those very long chain fatty acids. And we can do that using sodium butyrate and TUDCA, which Body Bio have both of those, and we use those all the time. You do need to use a quite high dose of those to really get those very long chain fatty acids cleared. And you're simultaneously, both sodium butyrate and TUDCA have benefits when it comes to the mitochondria and also benefits when it comes to the peroxisomes. So they help to reduce the stress on both those organelles because of their antioxidant properties and anti-inflammatory properties. But both sodium butyrate and TUDCA also have chaperone activity. And so chaperone is just a protein or a molecule that has the ability to go in and break down these misfolded proteins or lipids. And then we can use the Body Bio PC, the phospholipid complex, to wash all of that debris away. So that's a really beautiful trio in helping to clean up that burn it section. And then, of course, from dietary sources, we can accumulate these from dietary sources as well. So speaking of industrial seed oils, those are going to have very long chain fatty acids naturally in them. Foods like peanuts, mustard, soy, corn, canola, those are some foods that just naturally have these very long chain fatty acids in them as well, which again are neurotoxic. So we want to really clean up the diet as well as provide the patient with these supportive molecules that can help to clean up the membrane. Build It is going to be, it's going to show you the structural components of the cell membrane. So it's going to show you your saturated fatty acid status. So stearic and palmitic acid are the main saturated fats that provide the cell membrane with structure. And then we're also going to see a myelination index. So speaking of arachidonic acid and low levels of arachidonic acid, which we can, again, do by overdoing fish oil, suppressing not only linoleic acid, but all the downstream metabolites. What I often see is patients end up demyelinating when they have very low levels of arachidonic acid. So that is an invaluable marker because you and I both know that that's going to lead to potentially neurodegenerative diseases like MS. So we want to really make sure that we support that. And then we can use a targeted fatty acids approach for that. Now, when it comes to supporting the body with fatty acids, supporting with those essential fatty acids is key because, like I said before, those are essential. Your body cannot make those. We don't have the enzymes to synthesize them. But every other fatty acid in the body, we do have the enzymes to synthesize through that de novo synthesis process. So using stearic acid as an example, which we would get from animal foods, that stearic acid gets desaturated into oleic acid. So there's lots of emphasis out there on omega-9s and consuming lots of omega-9s. And omega-9 is important. Oleic acid is important. It's one of the 4 main fatty acids that are found within the cell membrane. But again, our body can make that fatty acid as long as we're getting in enough stearic acid and we're getting in enough amino acids to allow for the desaturation of that saturated fat to oleic acid. Then we have the Balance It, which is going to show us the essential fatty acid status, linoleic acid, alpha-linolenic acid, or the plant-based form of omega-3, and then all of those downstream metabolites. So linoleic acid is going to go into gamma-linolenic acid, that goes into dihomo-gamma-linolenic acid, that goes into arachidonic acid, and then adrenic acid. And then on the omega-3 side, most people are familiar with the alpha-linolenic acid, ideally getting converted into EPA and DHA, although that conversion on both sides is poor. The enzymatic activity is poor in general, but it actually diminishes as we get older. And then there's specific nutrients that also help to support the activity of those enzymes. So we obviously need optimal nutrition to support converting those parent oils to the downstream metabolites as well. So, and then the Stabilize It section is going to give you that PR index, which is the weighted index, the level of toxicity in which the peroxisomes are having to deal with. So that's where you can get really great insights, Scott, into is there mold in their environment? What does their redox look like? The stress in the environment is really evident by that PR index. And some people will have 500% above normal in terms of stress. So there's lots of little clinical pearls that you can glean from that test. And then it's going to show you your DMAs, which are plasmalogen markers, and whether someone might be demyelinating, like I mentioned before, and simultaneously overmyelinating. And both of these are equally bad. But we'll see that in the Stabilize It section. And then we're also going to get that fluidity index. So showing us how much fluidity are in the fatty acid tails within the cell membrane. And when someone has really high levels of omega-3 and low levels of omega-6, you see this increased fluidity, or what a lot of people could think of as leaky cell membranes. We can have a leaky gut, we can have a leaky blood-brain barrier, and we can also facilitate leaky cell membranes by overdoing omega-3 fatty acids.
I'm sure we will get the question for those that are vegetarian or vegan. How do they get an appropriate amount of stearic acid?
You don't. So it's a problem. Yeah, it's a problem when it comes to cellular health, for sure.
I want to talk a little more about the myelination, demyelination component. That was definitely an issue for me years ago when I did this testing myself, and I was doing some of the interventions like Prometal, for example, for the myelin support. So let's talk a little bit more about myelination, how you're incorporating lipids that may be necessary to support healthy myelination so that we don't eventually have more of a neurodegenerative condition. And then you mentioned the possibility of over-myelinating as well. So wondering, are there specific conditions where that is more likely to occur? I don't think many people think of over-myelination.
Yeah, so over-myelination, you're going to see a lot in autism. That's predominantly the main demographic of patient that I would see overmyelination in. But you actually see demyelination and overmyelination often in the same patient. So you'll have a couple of markers of demyelination and then another marker where they're overmyelinating. And ultimately, I had mentioned before, this is, overmyelination and demyelination, they're both equally bad. They're both signs of neuroinflammation. And then when you have that neuroinflammation and the immune system is breaking down myelin, or there's this hyper response to produce more myelin because of this inflammatory response, it's making sure that we remove the pathogenesis, speaking in Dr. Robert Navio's terms. So we need to remove the triggers. What's causing the neuroinflammation? Then we need to provide salugenesis. We need to provide those healing inputs. And then, of course, the patient needs to be an active participant in this whole process. So some of those healing inputs when it comes to myelination are using a targeted fatty acid approach to, again, build that reserve capacity so the body actually has everything it needs to go in and repair damage to the myelin. And so that would be phosphatidylcholine. That's one of the main phospholipids found in myelin. Sphingomyelin is actually the main component of myelin, and then phosphatidylcholine. And then we have arachidonic acid, linoleic acid, and oleic acid being the main fatty acids that are found within myelin. So we can use this beautiful approach using the body biophospholipid complex, the body biobalance oil. We can incorporate egg yolks, and we usually need to incorporate quite a few egg yolks to really build that arachidonic acid status. And then we can use things like the prodrome glia has been really beneficial clinically for us to help support oleic acid in that free fatty acid form. So it's directly feeding the brain. And it also does a really nice job of lowering inflammation in the brain as well. So you kind of have a dual effect using the glia. But that would be kind of a typical approach that we would use to support remyelination.
Let's talk about the phospholipids and the role that they play in restoring our cellular membrane health. Talk to us about the body bio-PC, how we might use that in a cellular restoration program. Is it supporting both the outer and inner membrane of the cell? Is it affecting the mitochondria as well? And what are some of the benefits that we might experience with the incorporation of exogenous phosphatidylcholine?
Oh, I love this question. So the cell membrane is comprised of roughly about 60% phospholipids in total weight. The outer membrane is primarily comprised of phosphatidylcholine, and it's about 50% phosphatidylcholine. So that specific phospholipid is supporting the outer membrane. Then we have that inner membrane that's primarily comprised of phosphatidylethanolamine, phosphatidylinositol, and phosphatidylserine. And the beautiful thing about the body biophospholipid complex is it's providing all four of those phospholipids and all four of those phospholipids in the ideal ratios for your cell membranes. So this is where that product, for so many reasons, just stands above the crowd. Now, when we think about supporting all the membranes of the organelles, I'd mentioned before that every single organelle within your cell also has a biological membrane. And if it doesn't, it's interacting with one. So this is the power of supporting membranes. We're supporting the cell membrane and simultaneously improving the health of all the organelles within the cell. The mitochondrial membrane is incredibly important because this is where about 90% of our energy is made. And phospholipids have been shown to not only improve redox potential, which is key for generating energy, but the mitochondrial membrane also has phosphatidylcholine as the predominant phospholipid on the outer membrane. And then phosphatidylethylamine is the most predominant phospholipid in the inner membrane, and this is where oxidative phosphorylation is occurring. So there's all these little cristae inside the mitochondria to increase the surface area. And then we also have this other phospholipid that is made by the ethanolamine membrane called the cardiolipin, which is where complex 1, complex 3, and complex 4 take place. So think about the significance of the membrane on a mitochondrial level. You have a breakdown on that ethanolamine membrane, and you're not able to synthesize cardiolipin, and you have a breakdown on the cardiolipin membrane. Now we're not even able to generate ATP. So the phospholipid complex from Body Bio has just proven, and again, I've had the great privilege of being able to see this clinically for so many years now. It really is the key to helping to restore mitochondrial function. And of course, there's all the other factors that we need to incorporate when it comes to environment, but the phospholipids are key.
So we're talking then about supporting things like brain health, the mitochondria, the heart, the liver, the lungs, the gut. I mean, these sound like pretty important things that we want to be supporting here.
Pretty important things to be supporting. 90% of the gut mucosa, Scott, is comprised of phosphatidylcholine. And when you look at studies on IBD, you see up to a 70% deficiency in phosphatidylcholine in those patients in the gut mucosa.
In some ways, I almost wish Body Bio had named their product something other than Body Bio PC, because there's a lot of PC products on the market, but correct me if I'm wrong, many of them only contain phosphatidylcholine, do not contain phosphatidylserine, ethanolamine, and inositol that you just talked about, correct?
Yes, but the other issue with labeling is that phosphatidylcholine, and I don't know if you've noticed this, Scott, in looking at literature, but choline and phosphatidylcholine are used interchangeably. So for whatever reason, we use these terms interchangeably, but they're completely different molecules. So when you look at a phosphatidylcholine molecule, that polar head group is the choline component. And then there's the phosphate group. It sits on a glycerol backbone and has those two fatty acid tails with these different positions that one is more of an anchor position and one can be interchanged within the body depending on what the cell needs. The Body Bio phospholipid complex is delivering the entire molecule. So you're providing your body with the exact materials it needs to go in and repair damage, the exact materials it needs to go in and support the mitochondrial membrane. You're not taking choline and then having to take that essential nutrient and go through what we call the de novo synthesis pathway, is how we make phosphatidylcholine in the body. That and also through the methyltransferase choline system. But the predominant pathway is through that CDP choline pathway. And so it's a completely, different molecule. So one is just providing you a substrate to synthesize phosphatidylcholine, which you know as well as I do, so many things can go wrong in that whole pathway, versus providing your body with the exact materials, the exact scaffolding it needs to go in and support the structure and the function of the cell.
I was going to ask this question later, but it fits nicely here. So in cases where someone does a micronutrient test and finds that they are choline deficient, are we able to address that deficiency then with phosphatidylcholine, or are they so different that that's not going to help a choline deficiency?
Oh, no, absolutely. You can use phosphatidylcholine to support a choline deficiency because it's part of that molecule.
Does restoring healthy lipids act as an oil change of sorts for our cells? In other words, if we have toxins that are embedded in our cell walls, maybe even attached to our mitochondria, as with the DNA adduct conversation, can we essentially support detoxification by providing the body with the right fats, with the right lipids, the omega-3s, the omega-6s, the phospholipids? Can we also then potentially have a detoxification reaction if we introduce, let's say, phosphatidylcholine and other lipids too quickly?
So yes, this is the most powerful way to support detoxification because you're building your own reserve capacity. You're supporting your body's ability to remove these toxins while you are simultaneously, clearing the toxins from the body. But Scott, when you look at all of the different ways in which phosphatidylcholine supports the body, you're looking at, when it comes to detoxification, you're improving bile flow by up to 250%. And actually, phosphatidylcholine is the main component in bile, along with cholesterol, bilirubin, bile salts, and electrolytes. We're improving the liver cell membranes, which is predominantly where detoxification takes place. We are supporting HDL. So phosphatidylcholine is a main component of actually all the lipoproteins. So LDL and HDL, but phosphatidylcholine specifically regulates that reverse cholesterol transport system. So HDL is passively, removing excess cholesterol from the cell membrane. It's intimately involved in inflammation. So I mentioned that we're supporting gut health. We're supporting the blood-brain barrier. We're supporting every single organ and tissue in the body so that you can adequately remove the toxins that you're exposed to. And the cell, again, has this miraculous innate ability to be able to do that when we give it what it needs. And then also that additional quality, like I mentioned before, that phosphatidylcholine can actually move into the cell and clear these intracellular toxins. So a lot of the tests that we run for, toxic load are going to be urine tests or blood tests. But to really look at the toxic load of the patient, to be able to see what's inside the cell and to be able to know that we can clear that using phosphatidylcholine. I mean, that's while building up the patient, supporting them, building reserve capacity, not depleting them more or putting them on binders or, all of these different nutraceuticals that really have a stripping effect. Phosphatidylcholine does all of that while supporting the patient from the ground up.
So if someone's cell membrane has, let's say, mycotoxins in it, for example, and we're bringing in these healthy lipids, phosphatidylcholine, and this broad spectrum of phospholipids, can we then potentially be releasing some of those from the cell membrane at a rate that maybe is too fast for someone early on? They then feel worse. They're having a detoxification reaction. Do we need to introduce phospholipids slowly?
I think that it's wise to always introduce everything slowly, especially when you're working with really sensitive patients. I personally don't think, a lot of people assume that they're having a Herxheimer or a detox reaction from the PC. I personally don't think that that's the mechanism of action, because I think if somebody was that sensitive to taking, half a teaspoon of PC and not pushing too many toxins, I just can't imagine how they would be able to survive in the world. I think that more likely what is happening is phospholipids are also signaling molecules. So they have these signaling properties. And I think a lot of people that have mold illness, as you know, have underlying mast cell activation syndrome as well. And so what is likely happening is these phospholipids are triggering the mast cells to degranulate. And in that, they're releasing up to 1,000 different chemical mediators, impacting multiple systems in the body. And that's what's ultimately causing the reaction. So I always recommend people get a workup for mast cell. And then sometimes we need to provide mast cell stabilizers to help stabilize those cells before bringing on phospholipids. Again, just because of those signaling properties. But I think starting low and slow is just a good idea for most people. And then working up to more of a therapeutic dose. And I know that you've mentioned before you take a tablespoon, and clinically we use really high doses, like between 2 and 3 tablespoons is pretty average for treating mitochondrial dysfunction for about a year it takes to restore mitochondrial functioning. And then we can come back down to about a tablespoon or so. But working up to that should be done slowly.
So I'll come back to the mast cell conversation in a little bit, but I wanted to talk about the comments that you made about phosphatidylcholine really helping with bile flow and maybe tie that into the SIBO conversation. So when we're talking about small intestinal bacterial overgrowth or fungal overgrowth or even protozoan overgrowth in the small intestine, it seems to me then that phosphatidylcholine has a place in the treatment of these conditions potentially, because the bile is really acting more like a detergent to help clean out the small intestine. So I'm wondering if you can talk a little bit about your experience in using phosphatidylcholine to support bile flow and how that might help your patients dealing with SIBO.
Yeah, I love talking about bile because it's so fascinating. And I think we don't give bile enough credit because we think about it as a product that emulsifies and helps with fat digestion and absorption. But bile has so many roles in the body. And speaking of SIBO, it's antibacterial, it's antimicrobial. But bile is also a signaling molecule. So bile is able to, when the gallbladder releases bile, when we release that CCK, and bile is released to help with the digestion of these fats and oils, it also signals to the stomach to make hydrochloric acid. So it's really assisting in digesting proteins. It's signaling to the pancreas to release digestive enzymes. So it's really helping with the digestion of fats, proteins, and carbohydrates. It is helping to regulate gut motility. And so there's so many, and then of course, all of the other characteristics of bile that we're familiar with detoxification. And, I think that we underestimate the significance of bile and bile flow. And so thinking that we can use phosphatidylcholine even just for that one, to support bile flow in these individuals that have gut issues is a really, really powerful tool that we have.
Another reason why I'm such a fan of coffee enemas too, because they really help with the bile side of this conversation. Coming back to the mitochondria and the role they play in health, supporting mitochondria is really almost necessary or foundational in recovering from chronic illness. And at the same time, supporting it too aggressively can, in some people, backfire if they're still in that cell danger response that you talked about earlier. So talk to us a little more about how phosphatidylcholine helps the mitochondria, how well it's tolerated if someone is stuck in an early CDR1 type stage of the cell danger response. And is that the primary tool that you're using for mitochondrial support, or is it part of a broader program? How are you supporting mitochondrial health in your patients?
So the phospholipids are a key tool for sure. And I don't necessarily think that using phospholipids will be harmful for anyone. I think especially if you start low and slow. So they're also necessary to help to get those patients out of the cell danger response. Because we know, Scott, there's phosphatidylcholine is very susceptible to lipid peroxidation. And so again, we often see this breakdown on the phosphatidylcholine membrane and then low levels of phosphatidylethynolamine on the inner membrane. And you almost see that, like clockwork again on these labs when patients run their first IGL. And then we can support them with these phospholipids and provide phosphatidylcholine and ethanolamine to improve cellular respiration and overall mitochondrial functioning. But there are definitely other things that we use clinically as well. So making sure that the environment is clean. We're really, really big on making sure that people have a building biologist come into their home and do an assessment, really militant about like hardwiring devices and limiting cell phone use and using different light bulbs in the home so you're not getting exposed to that 435 to 465 nanometers of light that's coming from, typical LEDs. We are getting people to use red light therapy, watching the sunrise, getting outside in the morning, getting as much sunlight exposure as possible. Grounding, that is a powerful way to improve redox, to just absorb all of those beautiful electrons from the earth through your sweat glands and your feet and your hands. If you can get down on all fours, that's ideal. So there's, the environment piece is paramount. And then we use these phospholipids, and obviously the dietary piece is incredibly important as well. And that's primarily my job. And I recommend the whole foods-based approach, predominantly animal foods, and eating according to the season. So really focusing on what would be growing at your latitude in each season. And we want to focus on those foods and make animal protein the main component of our meals.
One of the challenges that I personally have had with the cell danger response model, and I think Dr. Bob Nabiau is brilliant, and I've heard him talk about it many times, but the clinical application of it seems somewhat challenging. There's a lot of conversation about suramin, which is not available to most people. So are you suggesting then that the focus that we're talking about here on lipid replacement, on cell membrane health, that really can help move us out of a cell danger response over time?
Scott, I see that on repeat. It's very, very rare for me to not see a repeat test where their mitochondrial functioning has completely resolved. So I do believe that we can use this lipid replacement therapy approach or these phospholipids to completely restore cellular health. I do think that it's a lifelong thing. I don't think this is just a treatment like some people would look at. Other treatments are short-lived and then they go on and they live their life as usual. I think that we need to continue to support the body with these lipids so that we can optimize detoxification and we can continue to optimize cellular health. And we need that more as we age, because we know as we age, we have increased heteroplasmy. So that's mutations in the mitochondrial DNA, which are going to lead to chronic disease. We know that we have higher levels of inflammation. We have higher levels of catabolic reactions. We have decreased ability to synthesize phospholipids. So these phospholipids become more and more important as we age.
How does phosphatidylcholine affect our cholesterol? And for the most part, I've not ever been convinced that cholesterol is the big magic marker that conventional medicine likes to make it out to be. But I do think that sometimes optimizing our lipids, obviously, in the context of this conversation, very critical. And in those people that maybe have familial hypercholesterolemia, for example, maybe they do need to look a little more at their cholesterol. So what is phosphatidylcholine doing from a cholesterol regulation perspective?
Oh, I love this question too, Scott. So phosphatidylcholine is intimately connected to that feedback loop where the body makes cholesterol and regulates cholesterol in the membrane. And so when we have low levels of phosphatidylcholine in the cell membrane, the body ends up upregulating cholesterol production to support the membrane. And then we end up with this rigid, a cell membrane that has too much rigidity. But it's also phosphatidylcholine, I'd mentioned, is a main component of these lipoproteins. So phosphatidylcholine, let me just go back. Phosphatidylcholine regulates cholesterol synthesis through transcription proteins and through LDL, which is made in the liver. So just to remind everyone, LDL is what is delivering cholesterol to the cell membrane. But cholesterol is also a main component of LDL. So we often talk about these LDL particles and LDL being high. So the LDL production is going to be upregulated when there's mitochondrial damage, when there's poor redox, when there's high levels of reactive oxygen species. Because the cholesterol in the membrane, in the mitochondrial membrane, it's not only just found in the cell membrane, it's also found in the mitochondrial membrane. It's going to get damaged. And so that feedback loop is going to upregulate cholesterol production to go in and repair or provide support to the mitochondrial membrane and the cell membrane. So often when we see high levels of LDL, this is just the body doing what it needs to do to protect you. The body is always doing whatever it can to keep you healthy and keep you safe. And so that's when we look at LDL, we often need to look at it through that lens. Okay, this is likely a mitochondrial problem. This is a cellular problem. So how can we support the cell and get that feedback system back on point? But when we think about oxidized LDL particles, and how those are dangerous, right? Like a high LDL value doesn't really tell us anything because we want to know, well, what do those LDL particles look like? What's the size of them? Are they small oxidized LDL particles that are going to burst on the vessel walls? Or are they nice, big, buoyant LDL particles? And so by providing the body with phosphatidylcholine, we are supporting those LDL particles. We're supporting the membrane. And then also with HDL, the main component of HDL is phosphatidylcholine. And so by supporting with phosphatidylcholine, we're also supporting healthy removal of excess cholesterol from the cell membrane, or what a lot of people refer to as good cholesterol. Neither one is good or bad. They just are. But phosphatidylcholine is intimately connected in that whole entire picture.
And is phosphatidylcholine primarily going to, over time, help to reduce high cholesterol, or does it also have a role in those people who have low cholesterol, which in my thought process is sometimes even more of a concern than high cholesterol?
Both, because it's helping to support that whole feedback system. And Scott, phosphatidylcholine is a really potent, powerful antioxidant as well. So while you're supporting that whole system, you're also helping to support, protecting the cell from reactive oxygen species. And which is also why we see when someone has high levels of ROS that you see that phosphatidylcholine lipid bilayer get damaged.
So we were talking a little bit about fish oil potentially suppressing the immune system, kind of acting like a steroid. Do we have to be concerned at all if phosphatidylcholine is such a strong antioxidant and we're taking it regularly? Could that in any way negatively affect the body's ability to respond to and manage chronic infections?
No, it's acting very differently than omega-3 fatty acids because the protection is within the cell membranes and it's protecting those fatty acid tails. So that's another thing when we see high levels of lipid peroxidation, it's often because people have low levels of phosphatidylcholine in the membrane, because all the phosphatidylcholine is doing is protecting your cell. It's not like taking high dose vitamin C or high dose curcumin or something that we would think of as like an exogenous antioxidant.
When in a protocol might we consider incorporating these types of tools with lipid replacement? If someone, for example, has chronic Lyme disease or mold illness or a neurodegenerative condition, are you thinking about incorporating a focus on the cell and phosphatidylcholine and other lipids early? Or are you thinking about waiting until later? And one of the reasons that this question comes to mind is that if we are starting to remove toxins at the cellular level, it seems to me that we want to make sure that other emunctories or channels of elimination are supported first. We don't necessarily, at least in my thought process, wouldn't want to jump into this if someone is constipated, if their liver, kidneys, lymphatics are not well supported, if their extracellular matrix is not supported. So do we need to do some of those things first before we start unloading at the cellular level?
I would say no, because the phosphatidylcholine is going to simultaneously help all of that. And so really I think, Scott, the important way to look at these exogenous phospholipids, I know a lot of people look at them as supplements, but they're essential nutrients is what they are. It's not really in the category of like a supplement. It's providing the body with those essential nutrients that you need to be healthy, to heal, and then ultimately be healthy. So it's the first thing that we do is we support with phospholipids and fatty acids and get them on a nutrient-dense, whole foods-based diet where they can actually make sure that their body has everything that they need to do the work that needs to get done. So it's not, doing all of these other things first. It's starting on the cellular level is going to simultaneously support all of those other things that you listed.
You talked a little bit earlier about some of the dietary considerations if we're needing to, which is uncommon, but if we're needing to increase our omega-3s. Let's talk a little more broadly about dietary considerations when we're talking about improving our cellular health overall. What are some of the key things that you would consider incorporating?
So I mentioned before, I'm a very, very big proponent on animal foods. Just from a nutrient density perspective, I always make sure that everyone's meals are based around animal protein, primarily ruminant animals. So I put a large focus on grass-fed and finished beef, bison, lamb, pork, venison, and organ meats to make sure that they're incorporating liver, kidney, heart at least 3 times a week. And then to include seafood 2 to 3 times a week, kind of depending on the portion that individuals are able to consume. And really good healing fats, so saturated fats for cooking, and then supporting your essential fatty acid status, supporting with phospholipids, and then eating seasonally and the more and more that I learn about the seasonal eating, the more important I think this is, just because I think we underestimate how connected our mitochondria are to our location and the season that we're in. We're so connected to nature. And so I think we're living in Alberta and it's minus 30 and nothing is growing and people are eating bananas in the middle of winter. That's problematic on a cellular level. And so I do think it's really important that we stick to just consuming foods that would be grown at our latitude in the season that we're in.
I think that organ meats are a hard sell in some cases. So do you think that many companies that have emerged over the last several years that have beef liver capsules and things of that nature, do you clinically see that will meet that need or not?
I think that it would meet the need when we look at food just through a nutrient lens. But I don't look at food through that lens. I look at food through the lens of what is that food's relationship, or what was that food's relationship with sun exposure? And I think that if you look at Dr. Pop's work on biophotonics,
Here we go. Yeah, love it.
How food has a barcode, and that barcode is created by its exposure to the sun. And so when we take a food and then we put it in a facility and we process it and put it in a capsule, I think that changes it. And I do think that there's that scale, there's that good, better, best scale. And if that's the only option that people will take, then it's better than no option at all. But I do really encourage people to find a local farmer that's doing regenerative farming and order half a cow or a full cow and get those organs and consume them in their whole food form. There are a lot of farms now that are making blends. So I often buy a blend of ground beef with kidney, heart, and liver mixed in. And it's like 30% organs, 70% beef. So you don't have to deal with handling the organs. But I'm an exception to the rule because I love liver and heart, and I could only eat organs and be perfectly happy. So
another question I think that comes up a lot in the phosphatidylcholine conversation is the TMAO discussion, trimethylamine N oxide. How much do we need to worry that if we have gastrointestinal dysbiosis, if we have SIBO and we're taking phospholipids, that could lead to an increase in TMAO, which itself has other health negating effects? Have you seen that clinically?
So TMAO is interesting. We've never, ever seen anyone's TMAO rise through phosphatidylcholine supplementation. So I first want to say that. But I think the research on TMAO is a bit inconclusive. Just like cholesterol, I think we blame cholesterol for, cardiovascular disease. When I usually use the analogy, it's like would be blaming the fire department for showing up at a fire. That's basically, where we're at. And it's kind of the same thing with TMAO. I think TMAO production is largely dependent on, I'm not convinced that it's bad. I think it's an association, and I think it largely depends on the individual's genetics. It depends on their microbiome. I think there's a lot of factors that go into TMAO production. And again, I don't necessarily think it's a bad thing. When you look at seafood is really high in TMAO naturally, and we recommend seafood for cardiovascular health. And so there's a bit of a disconnect there. But I can say that we've never seen TMAO rise through using the body biophospholipid complex.
How do you compare phosphatidylcholine products derived from sunflower lecithin to something derived from soy? Are they comparable in their clinical benefits? Is there a reason that one might be better than the other? And then if we're talking about those derived from soy, like the Body Bio PC, and they are potentially allergic to soy, do you ever hesitate to use the PC? Have you seen anyone react to it from an allergic or sensitivity perspective?
So the composition of phospholipids in sunflower and soy is different. So sunflower is not going to have the same levels of phospholipids as soy has, which is why we use soy, because it has the highest concentrations, and those concentrations are most similar to our own cell membranes. Testing a lot of the products that are out there, we just haven't found the same benefit using any other product as we have using the Body Bio phospholipid complex. I know there's a lot of fear around soy. I want people to rest assured that the Body Bio phospholipid complex contains 0 soy proteins. So it is pure phospholipid. So when our immune system reacts to something, our immune system is reacting to the proteins or the DNA. It doesn't react to just pure fat. Now, so anyone that has a sensitivity to soy should be completely safe taking the Body biophospholipid complex, because again, there's no proteins, there's no DNA for your immune system to react to. But I think with somebody that has an IgE reaction or a true allergy to soy, that any product derived from soy could be problematic because of that homeopathic reaction that could occur. So I usually say that if you have an IgE reaction, if you're anaphylactic to soy, it's probably best not to consume the Body biophospholipid complex and to use something inferior, but because at least you're going to get some phospholipids. But for anyone else, the body biophospholipid complex should be perfectly fine. And again, we use it on, I would say 98% of the patients that we see. And most people are sensitive to soy, just because of the nature of the way that we grow it and it being so predominantly GMO.
Yeah. And I think in some cases too, I wonder how much of it even maybe is like a limbic system reaction where we assume that we're going to have a negative reaction because we think it has soy and we have some reaction to soy and thus we end up maybe having a negative reaction. And maybe it's not so much a biochemical allergic type response.
Yeah, exactly.
Yeah. So we talked a little bit about dosing. You mentioned 2 to 3 tablespoons. Is that kind of the sweet spot for daily use of the phosphatidylcholine? And then if someone's using the soft gels, and I may have this wrong, but I think it's something like 12 soft gels per tablespoon. So they'd be doing 36 soft gels a day. Talk to us a little bit about dosing.
So the dosing that we recommend for patients is always based on their labs. But I would say that the general recommendation, if I take all the patients that I've worked with and average the dose, it would probably be between 2 and 3 tablespoons. Sometimes we use more, specifically in individuals that have an active neurodegenerative disease. And sometimes we use a little bit less. So I do think it's important to consider body weight, size, metabolic demand, state of health or disease when we are dosing these things. But during a treatment phase, the therapeutic dose is high. And so 2 to 3 tablespoons would probably be what we typically use. Now, it takes roughly a year to restore mitochondrial functioning. So people really need to stay in it for the long haul. It's not this, short-term approach where we use phospholipids for 2 or 3 months and then can stop taking them. Again, we have probably between, I don't even want to guess, but we have billions and billions of mitochondria in the body, but there's between, 100 and about 1,000 mitochondria in each and every one of our cells. So we have 100 trillion cells. You can do the math. So we've got a lot of membranes to repair. And also we're repairing while we're simultaneously, getting assaulted on a daily basis as well. So it takes time. And after you get through that therapeutic treatment phase, which is typically about a year, I would say coming down to a maintenance dose. And this is going to vary a lot, Scott, on somebody's diet, right? Like for me, I'm eating lots of eggs. I eat liver. I eat predominantly, a meat-based diet. And so my need for exogenous phospholipids might be a little bit different than somebody who is a pescatarian or is living on the equator and they're, eating mostly plant-based. So yeah, I think it's just to give it a general dosing guideline, I would say probably 2 tablespoons would be a good place for someone to work up to if they were looking at really treating their mitochondria.
And that's something like 24 of the soft gels. I think,
yeah.
Right? It's a lot.
24 soft gels. Yeah, you're right. 12 soft gels is 1 tablespoon.
Okay. I was at one conference many years ago and I heard someone suggest taking the Body Bio PC product and blending it in water to make it liposomal, which didn't make a lot of sense to me because phospholipids are what many companies use to make their herbs or other supplements liposomal. So is there some benefit to mixing the PC with water? Does that somehow make it more effective? And is it just as effective mixed into a smoothie or a power shake as if we took it standalone?
So phospholipids, I don't think there's any benefit in mixing the phospholipids with water. I think that you can verify that it is a true phospholipid complex by blending it with water. Because you'll see when you do blend it with water that it just turns into this beautiful structure that is not going to separate. And when it comes to phospholipids and fatty acids, I should have mentioned this before because this is really important. You always need to take these with protein. So they should never be taken just on an empty stomach. So depending on what kind of shake someone is making, if they're making just like a fruit-based shake, I would say, no, you wouldn't want to take the phosphatidylcholine with that. You want to make sure that you're consuming it with ideally animal protein. And that's because the protein and these polyunsaturated fatty acids are going to form a bond as they move through the GI tract and protect them from lipid peroxidation. So that's key. I think that if people like shakes, it's a good way to incorporate the PC because you can mask the flavor a little bit if people don't like the flavor of it. I think you need to be cognizant of what you're adding to the shake because you need to remember that when you blend that phospholipid complex on high, you with whatever you have in your shake, you're going to blend everything into a liposome. So you're going to be pulling that right into the cell. So I usually don't recommend using, plant-based protein powders. And if you are using a protein powder, I always recommend just pulsing it in at the end instead of, doing that full blend with the PC. But it's a great way to add in, if you want to add in some turmeric or vitamin C that's not in liposomal form, or if you're in the summer and you're using some berries, you're going to, bind all of those polyphenols and blueberries into a liposomal form. So it is a nice way to kind of up level the delivery of these nutrients when you blend them on high with the PC.
Some practitioners use IV phospholipids and find that very helpful. When might we need to consider IV options, or can we generally get to a cellular membrane health that is really optimized with oral options alone?
I think that you can accomplish the same thing with oral as you can with IV. It just takes a longer time. So with IV PC, you're going to see a removal of those DNA adducts that I talked about really rapidly. And the IV PC is just phosphatidylcholine. So you're just providing that support for the outer membrane. So I do think that IV is a really valuable tool if you have access to it. But I don't like people to feel like they need IV PC because I have seen the same results clinically just from taking oral PC, the Body Bio PC at a high dose for a longer period of time. And I was one of those people. The very first time that I did, between my first and my second IGL, I didn't do any IV PC. I just took high dose. I took 3 tablespoons of the Body Bio PC, and I got the same results on my second IGL as any of the other patients that we see. So I do really think that it depends on the state of health of the patient. And then if you have a lot of those DNA adducts, you do want to get those off. I mean, those are impacting your genes. And we know, that they're going to lead to chronic diseases like cancer. So we want to clear those as fast as possible.
Where do plasmalogens fit into this conversation? You mentioned them earlier. You mentioned the prodrome glia. They are also a component of our cell membranes. So is there a synergistic effect to combining phospholipids like the Body Bio PC and plasmalogens? How do you use plasmalogens in a clinical setting?
So I do think that there's a place for them in a clinical setting. So plasmalogens are phospholipids, but they're made endogenously. So the Body Bio PC, we could consider essential nutrients. Those are exogenous phospholipids. And then we also make phospholipids in our body. Our peroxisomes are the organelle that make plasmalogens. And so those are endogenous phospholipids. And plasmalogens are primarily found in the brain and in the eyes and in the heart. They actually make up about 30% of the lipid content of the brain. So they're very important, but we can also support peroxisomal function, like I mentioned before, through using exogenous phospholipids like the Body Bio phospholipid complex, because we're supporting the peroxisomal membrane. We're providing antioxidants and anti-inflammatory molecules, and we're just making that whole cell work more efficiently. So you will see improvements in peroxisomal function just by using exogenous phospholipids. Now, in some individuals that have very, very low levels of plasmalogen, so I didn't mention earlier that we do occasionally run the prodrome scan, which is going to show phospholipid levels, both exogenous and endogenous. So it shows you those levels of plasmalogens as well. Now, I'm not as big of a fan of that test because it is plasma. And so it's hard to see, what does the long-term phospholipid levels look like, because that's pretty short-lived. But I do think that it's valuable, especially for people that have cognitive problems and you see really low levels of those plasmalogens. Then we know that we can support those with plasmalogen precursors to support the peroxisome's ability to make those those endogenous phospholipids. But there's other things that we can do as well. Strength training really helps to support peroxisomal function. And this doesn't mean spending hours in the gym. It's just working your muscle to fatigue, where you feel that burn that really stimulates the peroxisomes. Making sure that you're eating early and leaving a nice long fasting period between dinner and breakfast the next morning is also a really supportive tool. So there's lots of ways that we can support, our plasmalogen values without having to, spend hundreds and hundreds of dollars on a supplement. I think that the supplements, the precursors, could maybe be reserved for people that are, in a really dire straits and really needing that support.
And that's a good clarification, because these products like the prodrome glia, which I like a lot, they are not plasmalogens, they're plasmalogen precursors. So they're helping the body then to have the materials that it needs to produce plasmalogens. But as I understand, we can't get significant plasmalogens just from our dietary or supplement sources, right?
Well, we can. So scallops are a really excellent source. And prawns are a good source. So there are shark, which I wouldn't recommend eating. There are a couple of sources of whole food products that we can consume that can support plasmalogen levels. But yeah, they're technically, it's going to come from that organelle being healthy. Those healthy peroxisomes are going to make healthy amounts of plasmalogens.
Let's talk a little bit more about IgL and the DNA adduct conversation. I did the IgL testing before and after probably 50 lipid replacement IVs, and the results were significantly better, though I think it's hopeful, as you pointed out, you don't necessarily have to do the IVs. It may just take longer. So what does the IgL testing tell you? What is a DNA adduct? Why do we care so much about them? And what are the DNA adducts that you most commonly see with IgL testing? Are they more heavy metals? Are they more mycotoxins from mold exposure in our environments? Talk to us about IgL and DNA adducts.
So all the above, but DNA adducts, so they're chemicals like plastics, mold, antibiotics that get actually covalently bonded to your mitochondrial DNA, and they can actually get bonded to your nuclear DNA as well. But the IgL is showing the mitochondrial DNA, and they attach to a gene or a gene segment, and they're going to impact gene activity. So diseases can be directly attributed to DNA adducts, like I'd mentioned before. And these adducts also alter the nuclear DNA due to the epigenetic influence that the mitochondrial DNA have with our genome.
You mentioned TUD earlier as a chaperone. I remember having a conversation with Dr. Kelly McCann where she was suggesting that TUDCA could also play a role in helping to reduce DNA adducts as well. So when you see DNA adducts on an IgL test, is that part of what it's doing as well to help remove these DNA adducts from our mitochondria?
I don't know of any specific literature that shows that TUDCA can remove DNA adducts, but TUDCA has a massive impact on our mitochondrial functioning. And there's more and more research coming out around TUDCA and mitochondrial health all the time. But TUDCA is really known for reducing stress on the endoplasmic reticulum, Scott. It's been studied extensively around neurodegenerative diseases, both in prevention and also helping to support treatment of neurodegenerative diseases. And that's through a number of different mechanisms. It's reducing stress on the endoplasmic reticulum, so it's improving protein folding and it's improving lipid folding. So when we think about like aggregated proteins that are found in Alzheimer's disease, beta amyloid plaque or tau proteins, these are just an aggregation of these misfolded proteins. And so TUDCA can help prevent that from happening because it's supporting proper protein folding, but it also has the ability to act as a chaperone to go in and break down those misfolded proteins. And so there's, many, many positive effects of using TUDCA, both preventatively and also as a treatment.
We've heard a number of people talk about the prionic-like activity that happens with COVID, where we get these misfolded proteins, and that can really aggressively lead people into more neurodegenerative conditions. So is that something that TUDCA potentially could help with if we're dealing with misfolded proteins from prions or prion type activity?
Yeah, absolutely. And I do think that there's actual research on that very topic.
Let's talk about butyrate, which is often used in the IV lipid replacement protocol in the form of sodium phenylbutyrate. Wondering if you can talk to us about the role of butyrate in cellular health. Is it more limited to the health of the gut and addressing inflammation or potentially intestinal hyperpermeability? And how much of the role of butyrate is in the GI tract versus having broader systemic effects? Obviously, if we're doing IV sodium phenylbutyrate, that's probably more systemic. But what if we're taking oral butyrate, like the sodium butyrate that you mentioned earlier?
So sodium butyrate has a whole laundry list of benefits, Scott. And so I don't think it's only impacting the gut, but most of the research has been around gut health. There's also quite a bit of research around brain health as well. But sodium butyrate is an antioxidant. It's an anti-inflammatory. When we think about using it specifically for the gut, it is one of about 8 short-chain fatty acids. And there's 3 fatty acids that are made in the highest quantities. So that's sodium butyrate, acetate, and propionate. And actually sodium, I listed those in reverse. Sodium butyrate is actually made in the lowest quantities of those 3. But it is the most important for our colonocytes. So it's the main food for our colonocytes, are those cells that line the colon. It's also helping to support, there's a specific quality when it comes to sodium butyrate that it improves tight junction integrity. So when we think about pathogenic intestinal permeability, or what a lot of people would call leaky gut, it's going to help to pull those tight junction proteins back together so we no longer have that permeability. It's also lowering inflammation directly in the gut. It helps with GI motility. It helps to support a healthy population of commensal bacteria. It's also been shown to support the blood-brain barrier because the blood-brain barrier is made of those same materials as the gut. So there's so many benefits. There's benefits when it comes to liver health. It upregulates glutathione production through the NRF2 pathway, and also just through lowering inflammation and helping to support glutathione production and the recycling of glutathione. So and then with the brain, the neurons can actually convert sodium butyrate into beta hydroxybutyrate and use that as a fuel source. So that's another positive benefit. So it's not just, we're not getting benefits just in the gut. We're getting systemic benefits, and sodium butyrate is a signaling molecule. So there's a lot of people that say that taking oral sodium butyrate actually isn't even going to get to the gut or to the colon, but that's, in my opinion, it doesn't really even matter because it's supporting so many different systems in the body. And I do think that we see really, really amazing improvements in symptoms when it comes to gut health in individuals who take the sodium butyrate.
So the brain is mostly fat, and it's clear to me that your lipid program is working very well because your brain is working very well.
Thanks, Scott.
So when we're thinking about forms of butyrate that we might be taking orally, there's CalMag butyrate, sodium butyrate, there's the newer tributyrin forms as well. I've always been a little bit hesitant about the CalMag butyrate just because I think that sometimes there's potential downsides of lots of long-term daily use of calcium in general. I'm wondering what your thoughts are there. And does the tributyrin form have more of a systemic effect potentially than CalMag butyrate or sodium butyrate?
So the majority of the studies that I have read are on sodium butyrate. So I am very partisan to sodium butyrate. So I just want to put that out there because I get this question a lot. And I think there's benefits to the CalMag butyrate, and I think there's benefits to taking a tributyrin, but I personally use and recommend the sodium butyrate because that is the true biological substrate. So that's what's made through the fermentation of dietary fiber and other, methods now that we know. We can make short-chain fatty acids through the beta oxidation of fatty acids. We can make short-chain fatty acids through photobiomodulation or sunlight exposure. So it's not only fiber that makes short-chain fatty acids, but these are really potent anti-inflammatory molecules. And so sodium butyrate is the one that I personally use and recommend. There are many studies showing benefits when it comes to IBD using CalMag butyrate. And that's probably a specific condition that I see CalMag butyrate used most often. But when it comes to any of the neurodegenerative diseases, it's always sodium butyrate. A lot of the gut health research that I've read is using sodium butyrate as well. So That's my favorite and the one that I recommend.
When butyrate is low, that's often an indication that we have a microbiome that is unable to create butyrate. So then taking supplemental butyrate, that potentially can be a good thing. But I'm wondering, does that in any way signal then to our microbiome that the organisms in our biome maybe no longer need to create it because we have adequate or high levels? Could there be any negative feedback loop with exogenous butyrate that might be activated and thus have a potentially detrimental impact on our microbiome?
That's a good question. And I want to say I don't think so. I have never read anything that would show that that's the case. I do want to just say that having high levels of short chain fatty acids in your stool is not a good thing. There's a lot of confusion around that. I hear a lot of people say that they were recommended to take sodium butyrate because they had low levels of short chain fatty acids in their stool. But high levels of short chain fatty acids in your stool is actually correlated with cardiovascular disease and many other chronic disease processes. So I think that we underestimate the body's ability to, like, if you're using the sodium butyrate that you're making and you're not pooping it out, that doesn't necessarily mean that you just need to be, piling a sodium butyrate supplementation in. But I think that, like I'd mentioned before, that sodium butyrate plays so many other roles. So I really think that it's what are you trying to target is so important, because if you are trying to target your brain health or your mitochondrial health or your gut health or your liver health, your kidney health, there's research on taking sodium butyrate for stage 3 kidney disease. Like we're getting a systemic effect from sodium butyrate. It's not only directly in the gut.
You mentioned the two other short chain fatty acids as well, besides butyrate. Why is it that we hear the most about butyrate and don't really see any supplemental sources of those other short chain fatty acids? Or are they generally not in need of supplementation? Or what are your thoughts?
I think it probably goes back to that myopic focus that we have on these single things. I think it's also because sodium butyrate is the number one fuel for the colonocytes. So, when we first started studying butyrate, it was mostly in the realm of gut health. And so we know that taking, sodium butyrate levels are feeding those cells and helping those cells to be healthy. They're helping to improve tight junction integrity and then motility and all those other things that I mentioned. I forgot to mention too, Scott, that sodium butyrate is also a histone deacetylase inhibitor. So it was originally studied to be protective against colorectal cancer. But now there's studies showing that it's actually protective against all forms of cancer because of that epigenetic regulation that it provides, or epigenetic regulation support that it provides.
I want to come back to the mast cell conversation. It's such an issue in many people dealing with chronic complex illnesses. You mentioned earlier that the phosphatidylcholine potentially could lead to mast cells degranulating and thus releasing histamine and many other mediators. So is the mast cell activation piece, the histamine piece, is that something that we should address first before we then start to incorporate the phospholipids? Are there some people where maybe we want to address mast cell activation at the beginning and then do the lipid replacement later? And how do the tools that we've talked about, so the phospholipids, the TUDCA, the butyrate, how do those all either support or maybe worsen mast cell activation?
So I think that this is a really good question and topic to address, because I do think that with a lot of people that have mast cell activation syndrome that aren't able to tolerate anything, I mean, the number of patients that I see that are eating 5 or 6 foods and they're just reacting to everything, we first have to stabilize those mast cells before introducing these healing inputs like phospholipids. And I know that a lot of people don't like using pharmaceuticals. I personally had to take H1 and H2 blockers compounded to help support healing from mast cell. And so I had to kind of get over that mentality around not wanting to use pharmaceuticals. And now I see how much those H1 and H2 blockers can help support patients, that I do think that in many situations that they're needed. Then we can stabilize those cells, and then we can deliver all of those nutrients that the patient needs to get well.
So if someone's dealing then with mast cell activation syndrome, we may need to address that early on, before we start working with lipids, it seems to me that butyrate potentially would be helpful in people with mast cell activation if some of their mast cell activation is triggered by their intestinal hyperpermeability, their leaky gut. So what are your thoughts on butyrate in the mast cell population?
Yeah, I forgot actually to mention that's one of the main qualities that butyrate has is a potent mast cell stabilizer. So it's an excellent tool for anyone that is suffering with mast cell activation syndrome. But I do think that you always need to proceed with caution with these people because I've learned many hard lessons in working with these patients that you can't go by a study and then apply it to an individual most of the time. Because even some of these like really powerful potent mast cell stabilizers or, foods that provide us with the ability to break down histamine and stabilize, mast cells like, some of these powerful herbs, chaga tea is another really potent mast cell stabilizer, but it doesn't always, a lot of people react to these things. So I definitely stand by there's not a one size fits all approach. And so starting these things really slowly and methodically so that you don't end up having a really severe reaction is important. But ultimately, yes, when you look at studies on sodium butyrate, it has really, really powerful mast cell stabilizing qualities. And that's another reason why I love the Body Bio sodium butyrate is that it's so clean because so many of these supplements have excipients and it's really the excipient that the person is reacting to. It's not necessarily, the supplement that they're taking. So that's another advantage of taking the Body Bio sodium butyrate. It's so squeaky clean.
And how about TUDCA, either in the mast cell or ultra-sensitive patient population? My observation has been that TUDCA can be a very strong intervention and that some people maybe aren't able to tolerate it early on. So where do you bring TUDCA in? And are there any cautions around that in the mast cell population?
Yeah, I think with anything that you bring into a really sensitive patient, you have to proceed with caution. Now, TUDCA, I think it depends on, I wouldn't bring TUDCA in early. I think that the most important thing for those patients is to first support their cell membranes with these essential nutrients with phospholipids, because we know now there's research on this showing that in patients that have mast cell activation syndrome, there's a breakdown on those mast cell membranes. And so they need phosphatidylcholine as part of that stabilization process. So that's key. And then that's going to also enable them to get in the nutrients that they need to heal. TUDCA is a bile salt. So it's cholic acid conjugated to taurine. And it is made in the human body and has lots and lots of benefits. But I do think it's important for people to remember that if you are just using, high doses of TUDCA, there are studies showing that we can disrupt the bile acid concentrations and create these toxic metabolites. So it's not about using, more of this one therapeutic agent. It's really about finding balance and harmony with all these things that we take. And so I personally think if you're using TUDCA, you want to make sure that you're supporting with, cholic acid or ox bile so that you're supporting all those bile acids. Also remembering that TUDCA is a secondary bile salt. It's not actively involved in the digestion and the assimilation of these fats and oils. So for, people that don't have a gallbladder that are taking TUDCA for digestive support, that's not what you'd want to use. You'd want to make sure that you're using a bile supplement to support that. So I think that TUDCA is one I think shines when it comes to neurodegenerative disease, when it comes to supporting mitochondrial health, but I would bring that on board down the road after a patient is more stabilized.
You talked about H1, H2 blockers as a tool that you might need to use to support the mast cells, to support histamine in some of these patients before introducing some of these other tools. Do you at the same time early on work on the trigger of their mast cell activation? So if they were dealing with mold exposure in their environment or high levels of EMFs, how important is it to remove the nail from the foot or address the hole in the roof while you're also stabilizing the mast cells?
Oh, it's everything, Scott. Yeah, it's everything, which is why I really put a lot of emphasis on the importance of these patients have to be active participants. And there's a lot of people that are looking for, popping nutraceutical instead of a pharmaceutical agent to get well. And that's just not possible. It's so important for people to be living and breathing the way that they were intended to. And we need to get connected to nature. We need to make sure our environment is conducive to health. And this is a hard one for a lot of people to swallow, but most people can't get better in the environment that made them sick. And so it's either completely revamping your environment that you're in and making sure that it's safe and conducive for healing, or it's moving to a place that is safe and is conducive for healing. Because I don't think there's anything wrong with the human body. I think that we get sick because we're in an environment that is making us sick.
In your ultra-sensitive patient population, how important is a focus on nervous system regulation and or limbic system regulation to reduce their sensitivities?
It's huge. So if you know anything about Dr. Bruce Hoffman's work, you know that he works through a 7-level, 7-layer model. So there's no stone left unturned. It's a huge piece. And sometimes I think that that's the most important piece. You mentioned before that you think that some people's reaction to the PC is the fear of the soy. And so they have this reaction. And I see that all the time. And I don't want to make that sound like these symptoms are in someone's head, because that's not what I mean. But we can really drive that reaction just through those fear-based thoughts. And when we're constantly, chronically in this sympathetic state, I mean, the body cannot heal in that state. So if we do not learn how to regulate our nervous system, if we cannot get our body into that parasympathetic state, we are never going to be able to heal. So it's not kind of one or the other. It's all of the pieces of the puzzle that have to come together in order to provide that healing picture for patients.
Wondering if you've worked at all with BIA or bioelectrical impedance analysis as a measure of cellular health. Can you talk to us a little bit about intracellular versus extracellular water, how we get more water into the cells where we want it? And then building on that, if someone has a consistently low phase angle, what can we do to improve or optimize their phase angle?
So we actually run BIAs on every patient. So I also love this question. You can improve phase angle using phospholipids for sure. Phase angle is a marker of cellular health. So all of the things that I just talked about around improving mitochondrial functioning, improving redox potential ultimately is what is going to improve that phase angle. Now, getting water into the cell, I think that this is an interesting question because I think a lot of us forget that our mitochondria make water. They make the water that's in our cell. And this is that beautiful stage 4 water, that gel-like water.
The easy water, some people refer to it.
Yeah, exclusion zone water. And it has very, very different qualities than water that would be in a glass. So yes, we want to make sure that we're drinking clean water. And I kind of go to the extremes with this. I think it's important to be drinking, spring water at a high elevation, so it's lower in deuterium. It is squeaky clean. We're structuring it. We're adding those minerals back in that are going to help to support all those biochemical processes. And also we're giving that water a charge so that it is able to get into the cell and, support intracellular water. But ultimately that intracellular water is coming from improving mitochondrial health.
And when you say giving the water a charge, talk to us a little more about how you do that.
So there's a number of ways that I do that. I do use the Body Bio Light, which I think you're familiar with. So that's a potassium, sodium, and magnesium formula, and it's actually in the same concentration as human blood. So I love that electrolyte formula because there's no additives, there's no colors, no artificial flavors, sweeteners, or anything in it. It's just providing you with those electrolytes that you need to provide that optimal charge. And so I do use that. I use the Quintone hypertonic minerals as well. That's purified seawater to get in all those trace minerals. And I use a number of those each day. And then I use the Analemma structuring water wand.
That's what I use too.
I'm always structuring my water and infusing it with gratitude. It's a full-time job. So I'm sure that you know that. Every time I take a drink, I'm stirring with this beautiful wand, but it's so interesting to feel the difference in the water when you start to actually structure it. It's got this smooth, the consistency is so different than a typical cup of water.
It's interesting too, because they've reached out a couple times to do a podcast, and I haven't gotten to do that yet, but they actually have some interesting research suggesting that the structuring with the anyl-MO1 leads to research-backed benefits in mitochondria as well. I'm not sure if you would agree with that or not. But
100%. That's why I ended up buying one, because
okay.
the research was so compelling, and changes in brain activity as well with this structured water. So we underestimate the power of water. I just cringe when people tell me that they're drinking tap water. And I'm thinking, not only is this filled with like 200 different contaminants, from pharmaceutical drugs to chemotherapy to environmental chemicals, but you're also, this is an opportunity to provide your body with this like energetic life force. And we are like 50, 60% water. I mean, we decrease a little bit as we age, but we are predominantly water. So we need to be providing our body with the highest quality water.
I love it. I love everything that you're sharing with us. So as we wrap up, just wondering if there's any emerging therapies or interventions coming next that are really things that you're getting excited about.
I think I am so into light right now, like obsessed with researching light. And I kind of stumbled upon this because of, a personal health struggle. And I was so determined to figure out, what was driving this disease process and how could we stop it? And when I started to understand like all the pathways that light impacts, I've been blown away. And I'm like, why are so few people talking about this? Because we live in these environments that we are constantly getting this signal of this like really small frequency of light. I mentioned between 435 and 465 nanometers of light. So we're signaling to our brain that it's basically always noon, and our every single process that happens within our cell is dependent on that 24-hour clock, on that regulation. We have all these clock genes. So we are completely skewing every single thing that's happening on a cellular level by getting exposed to the wrong light. And that's when I, really dove into the research around photobiomodulation. So I've been, really obsessed with photobiomodulation. I don't think anything is better than actually getting exposure to the sun, but I've completely, revamped my whole light environment. I'm using near infrared lights and red lights and UVA lights, and just trying to mimic, the indoor environment as closely as I can to that outdoor environment, while also simultaneously getting outside as much as I can. But on a cellular level, Scott, those protein complexes have these chromophores on them, and these chromophores absorb near and red light. And it improves the transfer of those electrons along the electron transport chain and improves ATP synthase. So we can't not look at light. If we are interested in supporting cellular health and mitochondrial health, the light piece is absolutely key.
I love that too. Yeah, I use red light photobiomodulation probably almost every day. I use some other wearables that deliver frequencies on light as well. So I'm also a huge fan of light, sound, frequency, vibration, those types of tools, because I think they're incredibly powerful. So many people listening to this conversation, I'm sure, are going to say, how can I work with her? Are you taking clients? Can people work with you virtually? How might that work?
I do have my own practice, so they're welcome to reach out to me on my website and fill out the form. And if you're a body bio practitioner, I do clinical education for body bio. And so you can always book a time with me through body bio. They offer that as a service to their health practitioners. If you have questions about how to use these products in your practice, any clinical questions around the products, I would be happy to support you. I'm sure that you can tell I love talking about phospholipids and the cell.
And I can vouch for how helpful you are. I certainly have reached out to you a few times over the years with some of these questions, like the linoleic acid conversation that we were having, and your comments and experience and insights have always been tremendous. So thank you for that. My last question is the same for every guest, and that is, what are some of the key things that you do on a daily basis in support of your own health? I think we've already given many of them away, but...
Oh my gosh, Scott, people are going to think I'm a nut. So I get up every morning and I do a rebounding kind of workout with either a kettlebell or body weight squats. I don't turn on any lights. There's only red lights in the house until the sun rises. And so I use my red light device as I'm working out so that I'm not skewing my clock. We have a beautiful built-in sauna. So I go in the sauna for 20 or 25 minutes. It's like the typical old school Finnish sauna. So it's very hot. You can't really stay in there for much longer than that. I have a cold shower and I do my photobiomodulation before I get on with my day, and I take my breakfast and eat it outside in the sun.
Wow. I thought I did a lot of great things, and now you make me look like I need to get busy and start incorporating a few more. That's amazing. This whole conversation was just so incredible. I think this cellular health is so foundational. And I think, unfortunately, a lot of us aren't really incorporating some of the tools that you shared with us today. So I hope that it will really get people excited about the potential of looking at membrane health, membrane medicine, cellular health. You have made such a difference in this community. Your name comes up all the time in conversation with people, and you just bring so much to this community. I am so grateful for not only the time that you spent with us today and sharing a lot of your insights and wisdom, but what you do to help minimize the struggle of so many. So thank you so much, Justine.
Oh, Scott, thank you. That means a lot.
To learn more about today's guest, visit justinestenger.ca. That's justinestenger.ca. justinestenger.ca. Thanks so much for listening to today's episode. If you're enjoying the show, please leave a positive rating or review, as doing so will help the show reach a broader audience. To follow me on Facebook, Instagram, Twitter, or TikTok, you can find me there as Better Health Guy. If you'd like to support the show, please visit betterhealthguy.com/donate. To be added to my newsletter, visit betterhealthguy.com/newsletters. This and other episodes can be found on YouTube, Apple Podcasts, Spotify, Google Podcasts, and Amazon Music.
Thanks for listening to this Better Health Guy blogcast with Scott, your Better Health Guy. To check out additional shows and learn more about Scott's personal journey to better health, please visit betterhealthguy.com.